Hey, welcome back 8th grade to another edition of Math with Mrs. Cartwright. Alright, so in this one we're going to talk about two-step equations. So we just finished one-step equations, we're graduating to two-step equations. The way I think of two-step equations is I am going to work these backwards than we are used to in the order of operations. So normally order of operations we multiply or divide first, and then we add or subtract. Well, when we're solving, we're actually working our problem backwards to figure out what we started, how we got that answer. So 90% of the time, you're going to start by adding or subtracting. And I'm going to show you that other 10% in our examples as well, because I want you to be prepared. So starting out, here's our first example. Here I have 2x, 2 times x, plus 3 equals 15. So what I'm going to start with, and here you don't have to. I like to give my reasons off to the side. Sometimes by giving the reasons, it helps spark as to why we're doing what we're doing. This also, for those who are hoping to be doing geometry next year, gives you a glimpse into proofs, which is a big geometry thing. And so this is a start. All right, so I start with this is what's given to me. Now, in order to get x by itself, I have to zero out my constant first. So since this is a positive 3, I'm going to subtract 3. So I'm subtracting 3 from both sides. So that subtraction is my subtraction property of equality. I zero out the 3 on the left, and I'm left with 2x equals, and then 15 minus 3 is 12. Now my next step to get x by itself is I'm going to divide by 2, because that's the inverse operation to multiplying. And so I end up with 1x when I do that. And 12 divided by 2 is 6. And so that was the division property of equality. And if ever I question whether this is correct, I'm just going to plug it back in. 2 times 6 plus 3. So instead of asking your teachers, is this answer correct? You have the ability to type this into the calculator and see if it gives you 15. I'm not using a calculator right now, so I'm going to go ahead and just do it by hand. So 2 times 6, no, don't do that to me, is 12 plus 3, right? And 12 plus 3 is 15, so I end up with 15 equals 15, which means, yes, x equals 6, and my answer is correct. All right? So again, if ever you get an answer and you're like, I'm not sure if this is right, plug it back in. All you have to do is type that into the calculator and see if your left side equals your right side. All right, next example. Now this would be that 10%. I cannot add 7 with this divide by 3 here. Are you with me? So I need to actually start. So again, if I'm writing my proof, this is what we were given. We're given this equation here. But I'm going to multiply by 3. My reciprocal, right, because this is like a fraction, so the reciprocal of 1 over 3 is 3 over 1. And I'm going to multiply both sides by that 3. So that's that multiplication property of equality. And so my 3 over here will divide out, and I am left with x minus 7 equals, and then negative 12 times 3 would be a negative 36. Now I can take care of this negative 7, right, this minus 7. And so since it's negative, I'm going to add 7. That's how I'm going to zero it out. So I'm going to add 7 to both sides. That's going to be the addition property of equality. So it becomes 0 over here, and we get x equals, and then a negative 36 plus 7. I'm going to end up keeping the negative because the 36 is bigger, and then 36 minus 7 is 29. And again, if I'm unsure, then what I would do is I would do negative 29, because I'm going to plug it in for x, minus 7 divided by 3. And so negative 29 minus 7 is a negative 36 divided by 3, right? And then negative 36 divided by 3 is negative 12. And that is what I have over here, right? So that's how I know that I have the right answer. In this next video, we are going to go over how do we do word problems. Again, why am I doing it in another video? So that it's easier to go back if you're struggling on a word problem. You can just go back to the video on word problems. So I will see you there, 8th grade.